Suppose if we are throwing a projectile from like ground level, like from the bottom of a mountain or hill, and and we are modeling that mountain like an inclined plane. Suppose the angle of the inclination is alpha, and we are throwing it with speed u like that. Now, even though we are throwing it from the bottom of an inclined plane, the angle that we are going to measure is from the horizontal there. So this angle will be theta, correct? If I take, then the angle made by the projectile with the inclined plane will be theta minus alpha. Now what I will do, I will take this way as our x direction, and this way as our y direction. This projectile is going to take some curved path and is going to hit the inclined plane. So the logic is like same like earlier. Just the thing is, the acceleration that we have got along over this new y and x will not be same as earlier one. So once a projectile is in air, the net acceleration it's going to see is going to be still g and it will be down only. No? Now maybe projectile is really here. Now see projectile is really here maybe. So the acceleration vector, just I can shift that arrows anywhere else also. No? So net acceleration the projectile has is suppose that we know it is g. And this is the net acceleration. No? Now if I ask you what is the component of this acceleration will be, it can have two components. One will be this blue one. Some is noise man. And this another component will be this black one. No? And can you tell me what will be this angle alpha only?
Yes, sir.
So component of g which is perpendicular to the inclined plane is going to be g cos alpha. Component of the g along the inclined plane is, because they are having practice effect. Now the thing is, we have taken up the inclined plane as our positive x, and the effect of the net acceleration along the inclined plane direction is g sine alpha, but it is down the inclined plane, and we have taken up the inclined plane as positive x. So we can figure out how much acceleration it has got along x, that will be minus g sine alpha. And the component of the net acceleration g is along the minus y direction, and that is g cos alpha. So if I'll ask what is the component it will have along plus y direction, that will be minus g cos alpha. So same thing we do here. We write down x things and y things separately. Now the point from where I throw him, maybe I consider that as our origin. The point where it is going to hit the inclined plane. So this distance, okay, from origin till the point where it hits the inclined plane, That is something I'm going to call it as range. And for that, I'm going to use the symbol r. So the x coordinate here will be r, y coordinate 0. Now suppose at time t, our projectile reaches this point whose coordinate is x comma y. Now what is our initial x at t0 is 0. What is the x at final or at any time t? That is x only. If I ask you displacement along x will be change in x. That's going to be final x, the x at time t minus initial x which is 0. Same way displacement along y will be change in y. At time t y I am calling it as y, initial y 0. And what is the initial velocity we have got along x? So totally you can resolve u vector and it has got these two components, no? And how much angle it is having from positive x and positive y? The angle it is having from positive x is theta minus alpha. So the component it will have along x will be u cos theta minus alpha. I hope you get it. Component along y will be u sine theta minus alpha. The acceleration along x is minus g sine alpha. Acceleration along y is minus g cos alpha. Now the thing is, the acceleration whatever I have along x or y, they are constant only, no? Correct? And when I can say guaranteed, our projectile has reached the inclined plane. So whenever the projectile will hit the inclined plane, the y coordinate will become 0. Again, from what? 0. So displacement along y will be 0, no? So what was the thing that we had earlier to find time of flight? It's kind of same only, nothing different. So clear, no?
Yes, sir.
So to find time of flight, we are going to do the same thing. We'll find because how much it travels along x, we don't care about that, no? What is the thing which you can say if that happens, guaranteed the projectile is on the inclined plane. So it is not the displacement along x by which I can decide whether it is on the inclined plane or not. By checking out the displacement along y, I can decide, no? Whenever it reaches the inclined plane, the displacement along y, which is y, will be 0. So we'll write the equation of motion for the y. Sy equals uyt plus half of ay into t square. Displacement along y is y. Uy is u sine theta minus alpha into t, and ay is minus g cos alpha. When it is going to hit the inclined plane, y will be 0. So 0 equals u sine theta minus alpha into t minus of half g cos alpha into t square. So again, we are going to have two roots. One is t being 0. And what really it is telling us, the obvious thing that we know it already, that when t0, what is y is 0 only. So again, whenever y0, that is our time of flight, and that is going to come equal to 2u sine theta minus alpha by g cos alpha. So the formula is kind of same like the first formula of time of flight in vertical projection. T was 2u by g. So here also kind of same only. It is the initial speed along y by the magnitude of the acceleration along y. So time of flight formula kind of same only. So this part clear? This part clear, no? So we have thrown a projectile from O, reaches this point A. So the total thing that it travels along x is V, and that is what I'm calling it as a range. Time of flight clear to you?
Yes, sir.
Okay. So range really is what total displacement along x and how long it will undergo displacement along x till it is going to be in air. Only different thing here we have got some acceleration along x. So what? Still it is easy thing only because whatever acceleration we have along x is constant only. So range will be uxt plus half of ax into e square. What is ux? U cos theta minus alpha. E is 2u sin theta minus alpha by
Divided by
g cos alpha. And ax is minus g sin alpha. E square will become 4u square sin square theta minus alpha by g cos square alpha. G square cos square alpha. So if you simplify it, it's going to become 2u square sin theta minus alpha into cos theta minus alpha by g cos alpha minus 2u square sin theta sin square theta minus alpha into sin alpha by g cos square alpha. So suppose if I take these things common, what I'm taking as common as 2u square sin theta minus alpha. And in denominator, I'm taking common, that is g cos square alpha. So if I do so, what is the first term will become? Check that I'm correct or not. First term will be cos theta minus alpha into cos alpha minus of sin theta minus alpha into sin alpha. And that is fitting in, the bracket thing is fitting in this formula, no? Cos A plus B is equal to cos A cos B
minus
minus sin A sin B. So I'll be using that formula in reverse. That cos A cos B minus sin A sin B is equal to cos A plus B. So this term will become 2u square sin theta minus alpha by g cos square alpha. And this will be cos theta minus alpha plus theta. And that is going to give us 2u square sin theta minus alpha into cos theta by g cos square alpha. So this thing clear, no?
yes, sir.
Okay. So there is one way to write the range formula. See, this is like here itself I can stop, but maybe I want to use some trigonometry thing, that's all. Another way to write the same range thing is again using some trigonometry thing. 2u square sin theta minus alpha into cos theta by g square g cos square alpha we have. I will use this thing. 2 sin A cos B is equal to sin A plus B plus sin A minus B. So I'm calling this thing as A and this thing as B. So check out what it is going to become. It becomes u square by g cos square alpha. Sin A plus B will give us sin theta minus alpha plus theta. Sin A minus B will give us theta minus alpha minus theta. And that will be u square by g cos square alpha sin 2 theta minus alpha plus sin minus alpha. Sin minus alpha is what? Minus sin alpha. It's going to be u square by g square alpha sin 2 theta minus alpha minus sin alpha. Now the thing here is why we have done this much things is because if I tell you theta is the only variable and if I vary theta while keeping other things constant. U I am not changing, G I cannot change, alpha I cannot change. So only thing that suppose if I change is theta, then in this result, both the terms will vary, no? But in this result, only this term will vary. And you can say this sine term, this sine 2 theta minus alpha term, is it not directly proportional to the range? So whenever that term is maximum, then I can say range will be maximum.
Yes, sir.
So that was the reason to write this result like this. So for R to be R max, sine 2 theta minus alpha must become maximum, and that it can become is 1. For 2 theta minus alpha to be equal to 90.
90.
So for theta equals pi by 4 plus alpha by 2. So for this angle theta, what is the range we get?
Maximum
Maximum,
range.
and what it is, that I will write
10.
down. So that R max is going to be equal to U square by G cos square alpha into 1 minus sine alpha. This denominator thing totally we can write down as 1 minus sine square alpha. And 1 minus sine square alpha we can write down as
1 plus sine alpha, 1 minus sine alpha.
yeah, correct. Yeah, so it will become U square by G into 1 plus sine alpha. So the maximum range will be this much. For what angle it is? The angle of projection, that is pi by 4 plus alpha by 2. Clear, no?
Yes, sir.
Now what else we can find is what is the maximum height it's going to achieve. So we have thrown it with some speed u, making some angle, and it is going to trace a path like that. So whenever it's going to be at maximum height from the inclined plane, it will be only traveling along x, but with not constant velocity it travels. But still, the velocity along y will be 0, no? So time to reach maximum height will be same as like that earlier. That was half the time of flight. So here also it's going to be same. And at h max or at maximum height, Vy will be 0. So it's going to be same only. Vy square equals Uy square plus twice of Ay into displacement along y. At max height, Vy 0. So we get 0 equals Uy square minus of 2g cos alpha at maximum height displacement h. So h will be equal to Uy square by 2g cos alpha. This is not kind of same as the old result only. Uy square by twice of the magnitude of the acceleration along y, which is u square sine square theta minus alpha by 2g cos alpha. Time to reach maximum height still will be coming same as half of the time of flight, and that will be u sine theta minus alpha by g cos alpha. So that is the story of projectile up the inclined plane. It's easy, got it, no?
Yes, sir.
So next is projectile down the inclined plane. So it is up the inclined plane because thrown from the bottom of the inclined plane, it ends up somewhere on the top of the inclined plane. So it is called as projectile up the inclined plane. So down the inclined plane logic, everything same. Results will be different. So here, whatever results we got, we can get the results for the other one by doing some silly thing also. So here we have ux, u cos theta minus alpha. So you should derive this thing on your own. Here ux will be, you replace alpha with minus alpha. So it will be u cos theta plus alpha. Here uy was u sin theta minus alpha. Replace alpha with minus alpha, uy will be u sin theta plus alpha. Ax here is minus g sin alpha. So replace alpha with minus alpha, and sine of minus alpha will be minus sine alpha.
Yes, sir.
Cos of minus alpha will be cos of alpha.
Cos alpha.
So Ax will be here g sine alpha. So you also, without that also we can write Ay here is minus g cos alpha. Here also Ay will be minus g cos alpha. Time of flight 2u sine theta minus alpha by g cos alpha. Here time of flight will be 2u sine theta plus alpha by g cos alpha. Here h max was u square sine theta minus alpha by 2g cos alpha. Here h max will be u square sine theta plus alpha by 2g cos alpha. Every result will be like that. Here r is 2u square sine theta minus alpha into cos theta by g cos square alpha. Here range formula, that one will be 2u square sine theta plus alpha into cos theta by g cos square alpha. Here the other result of the range was u square by g cos square alpha into sine 2 theta minus alpha minus sine alpha. Here the result of the range will be u square by g cos square alpha sine 2 theta plus alpha plus sine alpha. In this case, R max is equal to u square by g into 1 plus sine alpha. For what angle? For angle pi by 4 plus alpha by 2. In this case, R max will be equal to u square by g into 1 minus sine alpha for angle pi by 4 minus alpha by 2. The results we can replicate, but we should know how to derive it also. Down the inclined plane, I will consider as positive x. And this way is our positive y. This green line is the horizontal from wherever we are throwing that projectile. And we are throwing this projectile with the speed u at an angle theta from the horizontal there to this angle theta. Now, if the angle of the inclined plane, I consider it as alpha, so how much angle here? This one will be alpha. So the angle made by the u with the positive x now becomes theta plus alpha. Or the angle u is having with the inclined plane is theta plus alpha. So one component of u will be down the inclined plane. Another component of the u will be up the inclined plane. This is u sine theta plus alpha. This is u cos theta plus alpha, correct? Now the way g is acting will be same only. Just our x direction is different now. So the component of the g, one of them was down the inclined plane, and another one was perpendicular to the inclined plane, like the way I have drawn it here. The one that was down the inclined plane was g sine alpha. One that was perpendicular to the inclined plane was g cos alpha. So the point from which I'm throwing it is origin. It takes a curved path going to hit the inclined plane. And down the inclined plane is our positive x. This is our positive y. So initial point 0, comma 0. Now wherever it is going to hit the inclined plane, the coordinate will be r, comma 0. So after that, every process same. Displacement along x, x. Displacement along y, y. Velocity along x, initial u cos theta plus alpha. Velocity along y, initial u sine theta plus alpha. What is the ax we are going to have? So right now, in this case, down the inclined plane is our positive x, correct? Down the inclined plane, this way is our positive x. So the component of the g is down the inclined plane only, which is g sine alpha. So what is the ax will be, in this case, plus g sine alpha. What ay will be, same like earlier one, minus g cos alpha. So time of flight, same process, range, same process. So can you derive it from here on your own, or you want me to?
Yes, sir, I can derive, sir.
Actually, you should derive. Only different thing you will have. In here, I'm using this formula, cos A plus B. In that derivation, you will use the formula of cos A minus B. Apart from that, everything will be literally same. Okay. So derive that result. You know the result already. Just to derive all of this on your own. Okay. So tell me any more doubts.
Sir, module question, sir.
Tell me which module. Which
Exercise 11. See, exercise 1, question number 11, sir.
which module? Projectile relative motion. Which one?
Vertical, sir.
Give me 1 second. I look in the module. Exercise 2, question number.
Sir, exercise 1, question number 11.
Exercise 1, question number 11. This one, is something. If I throw a projectile and I want to have same range for same speed but for different angle. So we have done that thing now. Just a moment, I'll solve this one. You got stuck in language actually. You know the answer. If I throw a projectile from ground, what is the range formula was? U square sine 2 theta by g. So if I take theta 1 and theta 2 such that theta 1 plus theta 2 is 90. So range for theta 1 will be u square by g into sine 2 theta 1. Theta 1 we can write down as pi by 2 minus theta 2 sine 2 times pi by 2 minus theta 2. And that will become u square by g sine pi minus 2 theta 2. And then some trigonometry thing. Sine pi minus 2 theta 2 will be sine 2 theta 2. That is the range for theta 2. Means if I throw projectiles with same speed but with the angles which are complementary, for that range will be same for both of them. Time of flight will be different. Maximum height they go through will be different, but the range will be same. So that is what is this question is. Just because they gave you some weird kind of looking angle, you got confused. Otherwise, nothing there in this question. So it was calculated from. So when we fire a projectile with some velocity at this angle, I get some range. So for what angle we are going to see the same range? It will be some angle such that theta 1 plus theta 2 will be 90. Correct. So theta 1 given theta 2 they are asking us. So theta 1 plus theta 2 will be 90. So for what angles range are equal for complementary? So theta 2 will be pi by 2 minus theta 1. And the theta 1 you take this one as 5 pi by 36. That will be 18 minus 5. So that is going to be 13 pi by 13 pi by 36. That's all. Understood?
Yes, sir.
Next out, tell me.
Sir, exercise 5, question number 1.
Size 5, question number 1. Same exercise, same module, no?
Yes, sir.
Okay, we will solve this one. So what is given here is for up to half part, the time g is different. For remaining half part, the g is different. If thrown a projectile reaches a maximum height, so up to there, the acceleration due to gravity is g. But from there onwards, the acceleration due to gravity is g dash. So total time of flight they are asking us. Okay. So maybe I will draw that remaining part with different color. Maybe this is yellow. So time taken to cover that blue part that we know that is the time taken to reach maximum height. So T1, the blue part is going to be U by G. T2 we don't know. The time taken to drop from maximum height to the ground. Correct. And we have to find total time which will be T1 plus T2. Correct. And I hope you understood what T1 means. T1 is the time taken to cover this blue part. T2 is the time taken, the time interval to travel from maximum height to the ground level. Is time interval basically. So how to figure out T1 we know, how to figure out T2 we don't know. So tell me, whatever the G now I have, it is different but still constant, no?
Yes, sir.
And when it reaches that maximum height, what is the velocity along Y is? 0.
Yes,
Correct.
sir.
So suppose that is our starting of the time interval. And the height it is going to achieve, it is going to be h, no?
Yes, sir.
And h we can find out that will be u square by 2g, no? Now we are going to solve for the interval which is from maximum height. Or maybe, suppose if I talk about that yellow interval, what is the velocity along y initial is 0? And when it reaches from here till here, the displacement along y will be how much? If I stick to the same sign convention, upward positive. So for the interval which is between maximum height to the time it reaches the ground. For this interval, if I ask you how much displacement along y is, minus h. So I'll use Sy equals uyt plus half of ay into t square. Initial velocity is 0. Displacement minus h. Acceleration is how much? Minus g dash. And time interval, that one I'm calling it as t2. So what t2 is going to become? 2h by g dash, no? But what is h? H is u square by 2g. So plug the value of the h, which is u square by 2g. So you get 2 pi g dash into u square by 2g. So 2 gone, and that will become u by root over g into g dash, correct? So total time is going to be t1 plus t2. Now we know t1 and t2 both. Just find it out. And they're asking us new range also. So the old range will be ux, which is same only, into t1 plus old range will be capital T, the old one. So new range I call it as t dash. So in case if g doesn't vary, the range was equal to ux into, I should have written 2u sine theta, ui I should write. It was ui, my mistake, I wrote u. Ui, so ux into t, that is twice of uy by g. New range r dash will be ux into t dash, and that will be ux into t1 plus t2. t1 we know how much t1 is. I'll write it nicely, just a moment. Ui by g, which is u sine theta, but I'm writing it as ui. So we get ux into t1 plus t2, and that is going to be ux into ui by g plus ui by root g into g dash, correct?
Yes, sir.
So ui I can take out common. So we get ux ui into 1 by g plus 1 by root g dash. Now you tell me what I can do here is I can write ux ui to be equal to 2 r by g, no? So I'll write it down like that, 2 r by g. So 2 r by g, no, not 2 r by g. ux ui is rg by 2, no?
Yes, sir.
Rg by 2. So it will be Rg by 2. One by G plus 1 by root G dash. And that is going to be equal to R by 2 into 1 plus G by G dash root over, correct? And what is G by G dash? G by G dash is 0.81, no?
Yes,
See?
sir.
So that
Sir,
will give us R by 2, 1 plus root over 0.8 sequence. It is G went inside, so G by G dash. G by G dash is 0.81. So is it going to become something solvable? So it is going to be R by 2, 0.819981, no? And that
Yes,
is
sir.
0.9. So 1.9 by 2. 1.9 by 2 is how much? 0.85, no? Correct? 0.85 only, no? 0.95 or 0.85, check out.
0.96.
0.95, yeah. So 0.95 into so nothing much in this question, correct?
Yes, sir.
The next out, tell me. Anyone else? He only came. Okay. One more person is there. Tell me what doubt you have, man.
Sir, I just came to attend the class, sir. Sorry.
Any doubt you ask me, okay? No?
Okay, sir.
Raghav, tell me any more doubt.
So that's all.
That's all. You tell me when any doubts. No doubt. No doubt, then no problem. You pause the recording then.